This is a falling seed. And this is a tiny electronic device.
The goal of this project has been to add capability for winged flight to electronic circuit chips.
Using seeds as inspiration, researchers have designed tiny electronics that fall slowly through the air, thousands of which could be distributed over a huge area.
For purposes such as environmental monitoring, maybe tracking the development of a chemical spill, tracking population movements, maybe disease tracking, things that could happen with tiny devices that are communicating with one another wirelessly in sort of a coordinated manner.
John Rogers and his team started out studying the aerodynamics of seeds.
Cottonwood seeds, maple seeds that have developed over the course of billions of years very sophisticated principles in aerodynamics, and we've been able to adapt those ideas, apply them to man-made electronic circuit platforms.
The spinning of the seeds stabilizes them and slows their fall, allowing them to spread further from the tree. The team adapted these aerodynamics for their electronic devices.
We use laser projection methods to understand how to create wings and the attack angles and the number of wings and the geometries and the weight distributions to fully optimize the way that these structures are flying.
So how do these tiny devices compare to the seeds that inspired them?
Well, we think we've beaten biology. In a sense. We've been able to build structures that fall in a more stable trajectory at slower terminal velocities than equivalent seeds. The other thing that we're able to do is we're able to make these helicopter flyer structures that are much smaller than seeds that you would see in the natural world.
But despite their tiny size, these artificial seeds are packed with electronic components.
It consists of an integrated circuit with wireless communication capabilities, a digital sensor. You need a power source. Maybe that's a solar cell, for example. It could be a very tiny battery, all integrated on a platform that includes the wings to allow for this controlled rotational flight dynamics.
The flyers are designed to be made with standard manufacturing processes, and the team have various ideas for how these miniature devices could be used.
One specific example that we demonstrated in this paper that combines all of those elements is designed to monitor particulates in the air, so levels of pollution as a function of altitude. So these devices are designed to fall at very slow rates, and so they have an extended interaction period with the atmosphere. And so when dropped at elevation, we can actually monitor, changes in ambient lighting, UV exposure, chemistry of the environment as these structures are falling to the earth.
As well as monitoring the air, the flyers could cover a wide area at ground level.
A chemical spill in an environment, for example, causing contamination in an environment that will vary over time. And so we envision a distributed collection of these tiny electronic sensors providing surveillance and data around the nature of that chemical spill and how it's evolving over time.
But John is keen that these devices don't become a form of pollution themselves.
We've been very interested in environmentally degradable electronic devices, so compostable conductors, integrated circuit chips that just naturally dissolve and disappear as they interact with groundwater, for example. So the environmental contamination, sort of the pollution, the litter associated with these devices naturally goes away.
And the team have even more ambitious future plans.
The other thing that we're thinking about is how to add active flight capabilities. So not something that just falls like a seed, but something that could fly away, like a housefly or something like that. That's much more challenging, obviously, but something that we think could be interesting.